RedisConf.
RedisConf.
Thank you for having us. We're excited to be here. We're SitePro. We're here to talk about the way we're using Redis Enterprise and the TimeSeries module to really drive our platform forward. Our platform is an IoT and intelligent control platform, so analytics are huge to us.
Well, before Aaron gets too far down the road, let me introduce this guy. This is Aaron Phillips. He is the founder of SitePro. He is a highly decorated entrepreneur, has a lot of industry success already at a very young age. He's been an inspiration to work with. He is driven to innovate. So I very much like working here and working with him.
Very much like working with you too, Dustin.
Oh, thanks, man.
You should have said it sooner. So this is Dustin Brown. He's our director of technology. He's got 20 plus years experience, places like Fandango, Motorola, Nokia. He was a consultant for Microsoft. He's always pushing the envelope for us. He's the reason we're diving into the whole TimeSeries piece. He really leads the way in a lot of that. He leads our dev team. He's been here for 2.5 years. His freshness always makes it feel like maybe he's been here a month. But then you look in GitHub and you're like, yeah, maybe he's been here the whole time. His impact is just wide-ranging like that.
Sleep is optional.
Very.
Let's tell them about SitePro.
Let's do it. All right. Awesome. So SitePro started back in 2012. We got our start in oil and gas. And really, it's kind of a funny story. The way it all started is, give you the Cliff Notes version. We met a group of people that really had a major problem on their hands. They had a pump that needed to run based on data that was occurring about a mile away. This was all taking place in a real small town called Cayusa, Texas. So it's one of those, if you go out there to fix it, there's no point in leaving until you fix it because it is a long drive back. So we're out there, me and my business partner David, we're working on it. And then you have that magical moment that I think a lot of companies experience early on that really gives them that spark to just want to push it to the limits. And it was when that pump reacted to that data that was happening a mile away. It was unbelievable. I almost get goosebumps.
I wish I was there for that. Yeah, I wish I had been there for that.
It sounds so simple, but it was just so amazing. So that really sparked us to want to see this whole thing through, like where can this go? IoT wasn't necessarily like a huge buzzword that was flying around at the time, maybe in some circles, but not ours. And so really our whole deal was how do we build out a platform that meets this need as well as work our way through both the supply chain and the business needs. And really that was the evolution of SitePro. And so we built a platform that did a few things, and some were built out of necessity because, when you're a startup, sometimes you try to fill gaps using code, and then it turns out they're incredibly useful. Some of those things being the no need for ladder logic. So we don't use ladder logic. Ladder logic, it typically takes days or weeks to configure something fairly complex.
We don't have that kind of time.
At all. No. So we're a startup, not a stall out.
That's right.
So the whole deal was how do we make something that people without a ton of low-level knowledge could actually configure these sites, because we had orders coming through the door and over half our staff were like college interns and stuff like that. So we built out this framework that actually allows you to configure an entire site as granular as you need it to be, all in a matter of 10 to 20 minutes. And so that was a huge leg up for us as we continue to kind of advance throughout the oil and gas industry and make our way into pipelines.
Probably the first massive barrier that the company achieved. Yeah, exactly.
And it's a much easier pill to swallow. The word modernization sometimes has kind of a negative connotation because sometimes it can sound dehumanizing, I guess. Mm-hmm. But when you realize that you're building things to really empower people and take away some of the monotony of their job so they can move on with their day and do things that really count and really satisfy them, I think the overall goal becomes much more important, right? And so another thing we worked in was the ability to do what we call intelligent control. So intelligent control really relies on any data source you can give it.
All the data sources.
Yes. If you can get it in a computer, you can get it into SitePro, and we can do something with it. Whether it's pumps, valves, sensors, I/O devices of any type, camera streams.
Cameras.
Love a good camera stream. You can do incredible things with computer vision and whatnot. And I mean, it's the same thing as if you were a person. And that's how a lot of this was designed. If we're being real honest, it's, you see people do things on a day-to-day in the industry, and it's like, hey, what made you decide to take that action or make that adjustment? And then it's how do you do that similar thing in your software to where that person doesn't have to worry about that anymore, and they can continue their day, because so many times your day can just get hung up on something so menial, right?
Yeah. Oh yeah.
And so that kind of gave birth to our intelligent remote control. Our intelligent remote control, what it does is, and this is where Redis first came in for us, a command is passed down from the SitePro cloud to an on-site location that's running a configuration, the whole no ladder logic configuration generated in SitePro. It's running that locally, and so it's got kind of its routine it's running through, making sense of what's going on. That remote control command comes in. Most systems would just execute it as is. And what we worked in was the ability for SitePro to actually assess that command, figure out what its potential outcomes might be, and if any of them are going to have a negative impact, whether it's burning up a pump, overloading a valve,
Spilling a tank.
yeah, exactly, or busting a line,
Yep.
right? It will actually discard that command and then respond in a user-readable way. Hey, we can't do that, and here's why. And it gives a full explanation, so it's a bit educational as well. And you'll see here in a sec how that comes into play as we really push the envelope and try to drive this whole IoT and intelligent control platform forward. So the scenario I just ran you through, it's very much a single site. You can think of it almost like a greedy algorithm, because it's only concerned about what it knows about, right? Well, there's a larger context to this, and it happens at the cloud level, because most of these locations are actually physically piped in one way or another into one another. Not only are we seeing that in oil and gas, but as we've ventured into the municipal market, the very similar setup, right? So the huge part there is that you have a situation where you have all of these facilities that aren't really necessarily aware of one another and what's going on. And there's actually a bigger goal that's happening in that system. Something needs to be aware of that, and something needs to kind of drive the bus. So if you think about each location as a child, then the system level context is it's apparent.
Yeah.
It's making sure,
They gotta share.
Right.
They gotta play nice.
Exactly.
Yeah.
Exactly. And no one's taking all the candy.
Right.
Right.
Well, if it's dinner time, everybody needs to eat accordingly. Not one kid gets to eat everything.
Exactly. But that being said, though, I guess if you have a ton of kids, it's not always possible to know what's going on in every kid's life. So that's where the intelligent control, remote control, plays a part again. So at the system-wide level, you're trying to modify the behavior of some of the certain sites to make sure that the overall goals are being met and streamlined. But if a command comes down that says, hey, site number 1, we need you to maybe open this valve up a little more and speed this pump up because we're trying to process more, that site still will process that command in its own context and say, well, that doesn't make sense because actually this pump is kind of old and it's not putting through as much and our tanks are pretty high. I'm pretty sure if we open that valve up, things will probably overflow pretty quick. So it'll respond back. And that's the whole deal. There's this whole trade-offs thing, but it's very much just like human interaction would work. Now, one level above that, though, and really where RedisTimeSeries comes in, is the ability to give historical context to real-time data. It sounds like an oxymoron.
What does that mean?
Let me tell you.
Okay.
So what it's really about is recognizing, hey, the system's moving into a certain scenario, a certain situation, and it could be good or bad. And we're headed towards this. Here's how it impacts the goal, or here's the troubles it could cause. Let's adjust. Let's make some modifications so that we either continue that way, maybe even faster if it's just a more efficient way to meet a goal, or maybe let's back off and work around this situation because the last 3 times we went into this situation, inevitably, whether it was in a minute, an hour, or a day, we ended up at this failure point, right? And at that point, you can not only alert people to come look at it, but also you can modify the way the system is running by passing that command down to the system level. It's like you think of the wise grandparent telling the parent, hey, we've been here before. Let me tell you how this ends. And then, tell the children accordingly. So it's a powerful chain. And the most powerful, obviously, is the wiser you can make it, the better you are. But the challenge that we've had is we have these legacy processes that are doing this, not only this historical aggregation and creating lots of statistics, which Dustin will be able to tell you all about because he is like many sleepless nights doing all of that.
Well, I was about to say and then the addition of all these more sites, more sites that we bring on, the more data that we start to ingest, right? And so we have to be able to make these intelligent decisions in real time. So a lot of these legacy processes that we do have cut. A lot of these legacy processes that we had were helping make those decisions in real time, but now we've got different alternatives that can speed up that process even faster.
Exactly. And obviously the faster it is, the better the decision is, because whatever it is reacting to or predicting, you keep those two timelines tightly coupled. And it's huge for us. That was the minute we heard about time series.
We keep dropping some jargon. Let's show them. Let's tell them. Let's give them a little context to what we've been talking about here. So our legacy stuff, we call those data crunchers. They're really ETL pipelines written in some containerized code running up in the cloud. And every one of our data types, sensor log types, has an associated data cruncher. And what they're really working to do is produce our downstream data. We call that groomed data. But really, that is just summary points along the log attributes. So a real simple example would be a reading or a value. And you might be getting these from a pump or a tank or some sensor in the field that is generating 1,000 logs a minute. 1,000 logs. So if I have to go look at that in the context of a 15-minute span, the performance hit on that is going to be pretty noticeable. If I offload that to something else so that it's crunching that data and I look at the summary point, then that is more valuable and it gives us a very concise representation of that log span. The last thing that we're going to be talking about, which we've already kind of given you the 3 context layers of, is the SitePro platforms. And that ranges from all of our mobile access to our business intelligence platforms to the command center application where people can interact with their facilities.
The edge.
The edge. The edge.
Where it all begins.
Where it all begins. So now let's jump in and talk about the legacy ingest process. So just as a high overview, as you can see here, what we've really done is constructed a bunch of data crunchers that are containerized units of code running up in the cloud, easily scalable up, down, but there's a lot of moving pieces in this, right? So
it's very brute force.
Yeah, the Edge API, then we're splitting up, sending some of it to Redis, some of it's going to Cosmos. We have changelog feeds that are notifying the data crunchers that they got to do work.
There's a lot that can go wrong.
There's a lot of moving parts. But it worked for us, right? I mean, as we needed to have groomed, more concise data summarized, this was a good approach, right? All of our downstream applications were able to consume this data at a much faster pace. It was a pattern we could work with. And you can see it was good, right? So we had our sample log here coming in. We're primarily concerned about the value and the reading, obviously. To give you an example of what our groomed data looked like, you have a 15-minute interval over here. It shows you the min, the max, the sum for all of the logs across that 15-minute duration of time. That's what the data cruncher was responsible for.
One thing that we liked about the data crunchers, or the idea of the data crunchers anyways, was being able to apply some more processing rules and logic, because not all logs are processed the same. A pump log has very detailed context level data in it, whether it be output voltage, temperatures, as well as speeds and whatnot, that really you discard some logs because they're not truly representative of the process sometimes. And being able to have that in the ingest process was important to us.
There was some not so good too, like the development costs, the ongoing support, the operational efficiencies and deficiencies, possibly, depending upon your opinion of how you want to look at some of that. But we ran the risk of representing an incomplete data set. Even though we have all the raw logs and we retain all of that stuff historically, what we were presenting in some cases might seem incomplete. Data cruncher might miss 2 15-minute intervals, and then all of a sudden on your visualizations or whatnot, you can see it pretty quick.
And there was no great way to tell the customer that, give it a minute and then it updates, because everything about our platform up to that point is real time.
It's real time.
And the other aspect is, like we talked about before, that historical comparison to real-time data to understand situations maybe you're heading into. There's a lot of extra work that's generated around making sure that the data crunchers are up to speed before you ever make a decision on it. Deciding if it's decision worthy, I suppose. And it added a lot of extra work outside of just the data worker.
Yep. What happens when we add a new log type? You gotta
do it all over
again, right? So this also increased our variable costs in terms of storage downstream, right? So we have all of this groomed data that we've got to put somewhere that our APIs and other processes can reach very quickly. That started to grow very fast. Then we got introduced to the RedisTimeSeries module. By happenstance, Redis Labs was alerting us that they had Azure, Redis Enterprise, and general availability coming up. We weren't even aware. So we walked through setting up our first enterprise Redis instance with them, checking off all the modules that were available, and we saw the RedisTimeSeries module. And
it was a showstopper. It's like, what is that?
Yeah,
tell us more.
I don't even remember the rest of that call. We literally just talked about the time series module because I think both of us realized instantly the impact it would have to not only our operations, but the cost and just the speed of us being able to deliver something that we'd spent a lot of time propping up and getting perfected to meet our needs, but we still had a ways to go before it could compete head to head with something like this. So before we decided, hey, this might work for us, we needed to do a little bit of research. Would it check off all the boxes to replace our legacy system? Or even, just a portion of it. And as we started walking through this, we started looking at the keys, we started looking at the Redis rules, and then we noticed they have all this built-in aggregation types. Wow, now we have labels, we can tag all this metadata with the logs that we're sending in, so now we can start to do aggregation across tons of keys based on unique attributes that they might share that we otherwise had never been able to really dig into.
And then the whole handling of time zones, I don't know. I know time zones are typically a total pain for any developer, but especially with daylight savings. You deal with these localized regulatory bodies that their version of the start and end of the day is obviously based on where they are, where they exist. And so we rely on this crunch data to also fill out some of the regulatory reporting requirements for our customers. And so ensuring that this properly handled that it wasn't trivial, but in the same token, it was clear how it could. And it was useful in that sense.
I think the other one was the time-weighted average too.
Oh, of course.
Because we had put a lot of effort into perfecting that.
And the rules you can put around it.
Yep.
Right. And that goes back to the whole pump piece. If you average the speed of a pump with all of its logs, and it only ran half the time, you're actually only going to get half the speed of the pump, right? But working in rules to where you only average it if it was running, now all of a sudden you get a true picture of what it was doing when it was running. That's just one example.
So let's talk about the first challenge that we solved for ourselves when we started looking at the time series. We realized really quick that we were going to have to flatten our logs out. And the sample log that we have here is very small and very concise. It's really just for these sample and representative purposes. But we had to figure out a way to flatten this data so that we could still manage to use it in the same capacity that we were today. So we started looking at the logs, and we figured we'll come up with a semantic way of representing the log and their attributes in the time series module. So as you can see here, we have the sensors. That's kind of our namespace for this guy. And the sensor 1, 2, 3, 4, 5, who's our most popular. And then its value and its reading. So as logs come in now, they just get applied to the time series module in these particular fields. So we rip the attributes off the logs, sync the values in the time series module. But the keys wouldn't be just enough, right?
No.
That doesn't replace all of our legacy code. So I mean, it gets us a really cool tool for having like some time series stuff, but it doesn't take care of the actual problem that we had. And the rules definitely open that up, because with the rules, what you can do is apply a rule to a key. Now you have to have a downstream key that the rule applies to, but you can add a predefined aggregation and the unit of time that needs to represent. So boom, all of a sudden we could create 15-minute and 1-hour keys and rules that responded to this data in real time.
And it also made it real simple to offer other intervals too, right?
Oh,
like
yeah.
That is the other piece of it. If we had a customer that didn't want to deal with raw data, but they also didn't want one of these, which I think everyone knows happens occasionally, then it's not too much of an ask, because you just go work that rule in there and have it start collecting that way.
Correct. So this is the way that we set ours up. It's a very linear process, but as you can see here, we have two primary key groups here for sensor 1, 2, 3, 4, 5. We have its value and its reading. And then we've created all our downstream keys that hold the summary data for each attribute and the time frame that we're interested in. And the rules engine takes care of the rest. It literally will take the data in real time and react. And you can go hit any of your downsampled keys and see the concise information that you're truly interested in. And then look at that, right? So this architecture is way less busy. And by less busy, I mean way more efficient, way more concise, and way more developer intensive. So the team can work on other really cool stuff too.
And as we have gone into these other industries, whether it's municipalities, agriculture, and whatnot, we really like to dive in, right? Become subject matter experts. And it lends itself to generating different types of logs that kind of structure data differently. Where we would have been headed had it not been for time series is to an episode of Hoarders Developer Edition. And it just would have been all these data crunchers just packed in there, and you're trying to figure out which one's not working and you're trying to look in the back. It would have been a nightmare. And so this really, as you can tell from the visual, cleans it up.
Yeah, and I think it's also very evident that the sunken cost fallacy of us having all of the time spent, all of the groomed data that we had already pre-processed, it was working. If you just shown me this diagram first, we would have never went down the data cruncher route. So
we do have a very high appreciation for time series having gone down that route. I'll say that.
But much like we empower our platform with innovative solutions, we are 100% on board with discarding any code that we have that can be replaced by similar improvements in our own stack. So now that we've kind of detailed out the good and the bad of our legacy processes and the amazing drop-in solution that RedisTimeSeries provided us to basically walk away from that, why don't we show you how we're leveraging Redis across the entire enterprise and primarily also focus on some of the time series integrations that are going to be pretty obvious. Let's do it.
So here we have our command center. This is on our demo site. So all of the data you see here is live, and obviously the site names are masked. On the right side, we have live widgets. This allows users to custom configure widgets that are showing key KPIs so they can understand what's going on in their operations. And all of this data is actually fed partially through Redis. So it's coming off the site, hitting our API and then spider webbing out to various WebSocket applications. We're anti-polling. We
don't
definitely,
poll.
yeah,
We don't poll.
it's just so unnecessary. And so instead, you can think of all of the data changes that occur out in the field as on-property change events, more or less, and it ripples through the system. And it typically can make it from a device to your browser in a second or less. And again, big thanks to Redis for that. We use the channels and everything. It's fantastic. So everything here is live. Down the left-hand side, you have all the different locations, as you can see, spread out across the US. When you click into a site, this actually takes you to what we call Insight. From here, you can do things like remote control. You can view your cameras. So every site, this is an actual site. So every site can be laid out by the customer. As you can see, it's very drag and drop.
This is WYSIWYG.
Yeah, exactly.
Yep.
And so this is actually a fairly in-depth site. They've really built it out with a bunch of logic. They've got their cameras they can stream in right there. It alerts you to motion, things like that. And again, customers can just kind of set it up however they want.
So in the context of things, this is the lowest context. This is the child.
Yep. And so as you can see, we click on a pump. We are then going to view different analytics about it. This is very useful to be able to actually make decisions. Maybe you're going to adjust some settings on a pump. You're trying to see how well it's been running. You want to see kind of the decision chain that's been being made. That's all available here. And you can do that for any of the items that are on the layout. In this layout, you can also set up various configuration pieces. You can actually set up the control logic for your whole site. So the other aspect of this is the remote control. So you can actually
that pump setting. Oh, yeah. Come on, pump setting. There we go.
So the other aspect of this is the ability, obviously, to configure your various equipment. And like we said, we don't use ladder logic. And actually, the power that is available in this panel is pretty wild. So you can do, when I brought up the example of using our system to configure something in minutes that would take days or weeks, this is a prime example of that. Pumps typically can have very intense configuration demands and logic demands, depending on what's around them and what their purpose is. And that can all be done here, point and click. We have a full device library, and it all just kind of locks in.
I think it's just very representative of all the data flying around in the system. Right?
Exactly. So all the points that are set up here result in real-time data collection and analytics. Those analytics are then really measured also on how the logic is working. So that's how you can kind of determine what data points maybe carry more weight than others. As you can see, it also has pieces in there based on the data we've collected, common pitfalls that people may encounter whenever they're setting something up. And so we give the user warnings on that to let them know, hey, you might be headed down a bit of a treacherous path. The other aspect of this is the remote control capability. So simply by hitting remote control, you would get hooked up to the remote control hub. And at that point, that data is coming in real time. Plus, there's additional data that starts getting kicked back as well to give you the comprehensive picture.
What is that remote control hub built on top of?
Redis. So now going into a site's dashboard, this is where we present KPIs that are pertinent to a given location.
I think I see some time series data.
That's right. So all of this actually is coming from our analytics workers, our data crunchers, as well as our RedisTimeSeries setups. Right now, like I said, it's a mix of the two. And, you're able to view historical information. We also try to give it all context. Like you can see on the alarms piece, we're actually saying in just regular sentence terms what's happening at a site and oddities. Now diving into, for instance, the pumps card, we're able to tell you how long a pump, for instance, spins in various states, whether it's running or under alarm, whatever that might be. And we can actually dive in even further and give you things like the utilization, because a lot of times this equipment's expensive. And if you're not really using it somewhere, you can move it around to another location.
Leaving money on the table.
Exactly. We're also able to break it down using things like Redis TimeSeries and whatnot and tell you the percentage of time that a piece of equipment spends in a given state. That's critical because that allows you to see why it's not being utilized like you had hoped. And you can then go and either adjust settings, or as we're targeting, we can auto adjust settings for you to up the utilization of that piece of equipment, comparing real-time data to historical data. So now hopping into the alerts panel, we break down all the alerts in terms of, you know, a big worry is always alarm fatigue. So showing, for instance, the running time series for active alerts stacked on one another. And then
the dashboard, more of the alerts.
Yep.
For some more context, you see the natural language down there, giving you context.
And then we also have, we talked about the whole cash register thing earlier, and how these meters are ultimately a lot of times how, whether it's municipality, oil and gas company, whatever it might be, that is the reason for being. So the statistics on those and keeping track of how they're trending and how they're doing is critical. And people will sit on, you know, views like this to really identify any oddities that they need to address, whether it be through remote control or a process change. So this is another view where we go into the alarms. The bubble charts you can actually break down and begin to dive in and dissect where the issues are coming from. You can have it broken down by, you know, location, then alarm type and equipment type, all the way down to the specific piece of equipment, whether it's a small I/O device or a pump, whatever that might be. And we'll also dive into that later in terms of some visualizations that really make it clear without having to do a lot of clicking. There's a sunburst.
Oh yeah, beautiful.
Yeah, kind of gives you a full picture so you don't have to click in too much if you don't want to.
And this is all being powered by the summary data.
Yep, that's exactly right. Yeah, everything you see in terms of any of the dashboard stuff, graphing, anything like that, is fed from that. The tables down below are actually summaries over this time period that lay out, for instance, the frequency of these various alarms, as well as kind of if more are happening. It's a great indicator. Maybe settings could be adjusted, or you have an issue there at the site. It gives you like the time in between occurrences as well as the duration of the occurrence. So going into our enterprise intel,
Yeah.
this is where we really open it up
Yep.
for our users. So this is broken out by location, and then all our data has all these complex layers to it, right? And you can pick and choose how those layers are displayed, calculated, and everything else, to where you can really dive in and make meaning of all that data that we have stored in our Redis TimeSeries. It really performs kind of
It's fast too.
yeah, it is cool. It is cool. It performs a very valuable tool simply from the perspective of you're not looking through a bunch of data grids and whatnot. It's very clear visual.
Mm-hmm.
One of my favorite visuals, obviously, the Sankey.
Yeah. Sankey.
And this is very useful. So this is actually charting the origination of alerts, and it charts it all the way over to the actual piece of equipment that would be generating the alert. It's incredibly useful. If you're seeing a lot of noise coming out of a site, what better way to view it than a slick animation showing a flow.
Really drives it home.
It does, big time, big time.
Very cool. Yeah.
Here's charting for our tickets. So these are volumes coming off of various
I
facilities.
mean, how could you have ever plotted this much data without
You couldn't.
the time series?
Yeah, you couldn't.
It just would have been
Not at that speed, you know. And so if you want to also compare, for instance, how hard your location is working in terms of certain equipment, you know, whenever you have a volume spike or whatever it might be, or a just an activity spike, you can go in and select various pieces of equipment to instantly just graph against.
Look at that. Max, count, min, sum. What?
Where have we seen that before?
Beautiful.
So this allows you to do that, and there's lots of little tools in there that really expose the granularity and just the power that Redis TimeSeries is giving us. Because again, to have done this previously, it would have been a massive effort.
You would have needed some native software running on your computer.
Exactly.
Which, don't get me wrong, Grafana is amazing. But we want something in the cycle of our product that can also equal that.
All right, well, thanks for hanging in there and stepping through that demo with us. Hopefully you were able to see not only the ways we've worked Redis into our platform, but the real impact that things like the Redis TimeSeries are having on our platform.
We're not done yet. We're done with the session. We'd love for you guys to stay engaged with us through this process. So we've offered up a few more resources. There's a HelloTimeSeries that's available on GitHub, where you can just basically get some starter code, kind of see some of the higher level practices that we implemented to do things we've done in Node. And then there's a dev.to where we'll continue to blog our journey as we wrap up our initial time series and start exploring some of the other enterprise modules that are available. So I think as we wrap up, the key thing to take away is planning is key. Understanding the product as a whole and knowing what's possible, A to Z, will help you plan accordingly.
Yeah, big time. You know, if you really sit down and really look through it before you hop in there, it's actually pretty straightforward once you understand the different little concepts to really start pumping your data in there and getting value right away.
And it was very easy. Rarely do we encounter something where day one we get it up in Azure and we can start leveraging it and using it. With the enterprise module, we definitely did.
Yep, definitely.
Thanks.
Yeah. Hey, hit us up. You guys ever want to collaborate on something or got questions, whatever that might be? We got, our emails, Twitter at the bottom. Feel free to reach out. Thanks.
Have a good conference.
Whoop, whoop.